Runner shaping is a crucial step in the process of cylinder head porting. This stage directly influences how efficiently air and fuel enter the combustion chamber and how exhaust gases exit, impacting both engine power and efficiency. To begin, it's important to analyze the existing runner shape with a critical eye, understanding the role each runner plays in the engine's breathing dynamics. Start by examining the intake runners. These passages are responsible for carrying the air-fuel mixture from the intake manifold into the combustion chamber. The primary goal here is to promote high air velocity and smooth, uninterrupted flow. A well-shaped intake runner typically maintains a consistent cross-sectional area along its length, avoiding abrupt changes that could cause turbulence or restrict movement. As you study the runner, look for any areas where the shape becomes irregular, narrows suddenly, or introduces obstructions that might impede the flow. Turning attention to exhaust runners, the considerations change slightly. These passages must efficiently expel exhaust gases after combustion, clearing the chamber for the next charge. Here, the focus shifts to maximizing flow volume. Exhaust runners often benefit from slight enlargement, as this helps reduce back pressure, allowing spent gases to escape more freely. However, any modifications should be done thoughtfully to avoid negatively impacting other aspects of engine performance. Once the analysis is complete, the next task is to remove any restrictions within the runners. This is where the use of a cylindrical burr comes into play. Casting imperfections are common in factory cylinder heads. These can include flash, small bumps, or rough areas left over from the manufacturing process. Such irregularities, though seemingly minor, can disrupt airflow, causing turbulence and reducing the efficiency of both intake and exhaust processes. With the cylindrical burr, carefully remove these imperfections, smoothing out the inner surfaces of the runners. Pay particular attention to the valve guide bosses. These protrusions can significantly restrict flow if left unmodified. Similarly, examine any tight bends within the runner paths. These areas often accumulate excess material that can be judiciously removed to open up the flow. It's crucial to approach this step with restraint. While it might be tempting to enlarge the runners substantially in pursuit of maximum flow, doing so can have unintended consequences. Excessive enlargement reduces air velocity, which is detrimental to low-end torque, the engine's ability to produce power at lower RPMs. Maintaining an optimal balance between flow volume and velocity ensures that the engine remains responsive and powerful across its operating range. After addressing restrictions, focus shifts to the actual shaping of the runners. Switch to an oval or tree-shaped burr for this stage. The goal is to create a smooth, tapered shape that guides air or exhaust gases efficiently through the passage. For intake runners, aim for a gradual taper that becomes slightly narrower as it approaches the valve. This design increases air velocity at the critical point just before the air-fuel mixture enters the combustion chamber, improving cylinder filling and combustion efficiency. The taper should be subtle. Too abrupt a change can again introduce turbulence or disrupt the flow pattern. Exhaust runners, on the other hand, should be widened slightly as they move toward the exit. This subtle increase in cross-sectional area helps reduce back pressure, making it easier for exhaust gases to escape rapidly after combustion. Remember, every change should be smooth and gradual. Sharp transitions or sudden expansions can cause undesirable flow characteristics. Throughout the shaping process, symmetry is key. Each port on the cylinder head should be as identical as possible to ensure consistent performance across all cylinders. Inconsistencies in runner shape or size can lead to imbalances, with some cylinders receiving more air and fuel than others. This can cause uneven power delivery, increased emissions, and long-term engine reliability issues. To maintain symmetry, regularly compare your work on each port, using templates or measurement tools as necessary. It's also important to periodically clean the work area inside the runners during shaping. Metal shavings and dust can accumulate, obscuring your view and potentially leading to mistakes. Take your time, work methodically, and inspect your progress frequently. As you refine the runner shapes, remember that ultimate performance is not just about maximum flow. The objective is to create runners that balance flow volume and velocity with smooth, unobstructed paths that gently guide gases where they need to go. The work you do here lays the foundation for the cylinder head's performance, influencing everything from throttle response to peak horsepower. After shaping, a final inspection is essential. Shine a light through each runner, checking for any remaining rough spots, sharp edges, or asymmetrical sections. Run a finger along the surface to feel for inconsistencies that might not be immediately visible. If necessary, go back with finer burrs or abrasive rolls to further smooth the surfaces, especially in areas where airflow is most critical. In summary, runner shaping is a blend of science and craftsmanship. It requires a deep understanding of airflow dynamics, a steady hand, and a careful eye for detail. By analyzing runner shapes, removing restrictions, and shaping for optimal flow, you set the stage for significant gains in engine performance. The process demands patience and precision, but the rewards, improved airflow, increased power, and a more responsive engine, are well worth the effort. As you complete this step, take a moment to appreciate the transformation underway. The runners, once rough and restrictive, now serve as finely tuned channels, purpose-built to harness the full potential of your engine. With runner shaping complete, you're ready to move forward in the porting process, confident that you've made a critical contribution to enhanced performance and efficiency.